Welcome everyone. Today we have our another new episode. And this episode we will discuss on robotics. We have our world famous speaker, Professor David Smith, Professor Rob, Professor Hutchings. I just want to declare another good news. Already we share in our social media group. Uh, Actually, we have a big debate in 24th December, Friday, 11 p.m. Malaysian times. Our topic will be this house believes that humanity should fear advance in artificial intelligence. And all of the famous speaker like Professor Rob, Professor David Smith, they will join. Mr. Hutching, you can join as a adjudicators and audience. It will be very popular, I'm sure, because already we are working with Oxford Union and Cambridge Union in Malaysia. We have a IIUM Oratory Club. They're also working with World Talent Economy Forum. I'm sure many students, universities, they will be our audience, and we will heavily promote it in different media. So I'm happy that we have our for this debate already. Professor Rob and Professor David Smith, they agree as a debater they will join. So I request all of our audience, uh, just take your preparations. It will be very interesting debate, and you can learn a lot of things from this topic. So today we will discuss about robotics. So first I want to give chance Professor David Smith. Can you unmute, please? Yeah.
Yeah, I was trying to get my mouse to go down there. I think it's about that's we've been talking about robots and cobots and some other things, and the whole area of robots is one that is going to be going through tremendous growth. And in 2019, the global robots market size was about $63 billion. And by 2027, it's expected to reach about $200 billion with a compound annual growth rate of right at 14%. And what's interesting with robots is it's the intersection really of technology, of engineering, of science, of sensors, of mechanical engineering, of power sources, software, AI, and advanced sensors. So it's a lot of things beginning to pull itself together. And it's in a many different verticals and industries, manufacturing, healthcare, agriculture, the personal service industry, the home industry, automotive. So again, many broad places that it can be used. And one of the biggest trends of the last couple of years is that it's also working in some of the more interesting areas of healthcare. And we talked in some of the other shows about how collaborative robots, cobots, are making a dramatic growth in the whole robotics area. So you have industrial robots, you have cobots, you have medical explicit robots, which are different than those two. And you're seeing even them in restaurants and homes and beginning to grow a lot. So it's a great introductory field to get into. It has a global footprint and global markets. And robots are beginning to work with digital twins, which is a very interesting trend I see as well. But it's one which, because of the various sciences, technology, engineering, software, and everything involved, it's one where there's opportunities for a lot of nations, a lot of companies to play in it as it goes forward.
Thank you, Professor Rob.
All righty, that was fast. Robotics. So the big change in robotics over the last couple of years has been not only the entry of a series of new companies into the space, like Boston Dynamics, who's doing amazing work. I was owned by Google for a period of time, spun out, but it's still probably doing the most advanced work with regard to industrial and military robotics, robots that move like robots. In some of the other countries, robotics is evolving into the military arena with robots that are weapons carrying and increasingly autonomous. That's driving a certain amount of pushback in terms of people looking for legislation and regulation surrounding those robots. New Zealand has taken the lead in this, but the difficulty comes when you're talking about robots used for the military. Is if you don't do it, you may be vulnerable to countries that do it. The best defense against a militarized robot will undoubtedly be another militarized robot. So the difficulty in getting the regulations in place for any military technology is proven elusive, and this one has been way too attractive at the moment. One of the big advancements we've seen with robotics is the metaverse, and using the metaverse as a training arena. So the robots are trained in the metaverse and not trained in a real environment. Robots include autonomous vehicles. They include autonomous drones and also include autonomous ships, which means that those autonomy systems have started to migrate over to robotics. If you can build a car that can navigate a complex environment, then you can use that same technology to develop a robot that does the same. What's been interesting since the beginning is who really got excited about robots first, and it was the automotive industry that seemed to embrace this, mostly the Japanese automotive industry that embraced this early on. And it's only relatively recently that the technology industry has picked it up. You could argue that NVIDIA probably has the best stack right now in terms of technology for robotics. Everything from computers that will go on the robots themselves to a very robust training suite in simulation, so you can do your training in full simulation and then push out an inference to the individual robots. That's allowing for a tremendous amount of advancement. And then Lenovo is recently, the Chinese US bridge company, has jumped into robotics as the first. And which makes that interesting is Dell was the first company to pop up at one of their Dell World events and talk about robots as the future of technology, and really put forward numbers that would suggest that we'll have robots that will exceed the numbers of cell phones and personal computers combined once they reach stride, because we're going to have them not only all over our fast food industry, restaurants, manufacturing, but also in our homes. And there could be 2 or 3 robots for every human by about 2040. So the proliferation of these things is expected to go vertical. And it's just been kind of interesting that Dell called it out first, but Lenovo actually entered the segment before Dell did. So this is an area fraught with danger. It's an area fraught with advancement at a very rapid rate, and a lot of cross-pollination between the different components, the different areas of robotics, going from, as David pointed out, medical all the way over to the military, and including an increasing number of wholly autonomous systems, including for delivery both by air and ground. So a lot of change here, tremendous amount of growth, and a great place for an emerging economy to get involved, because we're still very early on these autonomous robots. Clearly, we've had robots in manufacturing for a long time, but the autonomous robots are what's new, and they're the things that are going vertical.
Thank you, Professor. Professor Hastings, there is a specific question for you. Which was the first industrial robot? Can you guide our audience? And is there any law for robotics? Or something like that?
Well, this is a subject for me and for our organization. Our organization right now focus on robots. So also I will comment that all we need to talk about is this one subject, robot, which involve everything. Our friends just say that. The question is how to build a robot which can replace all human physical and routine works. If we can do that, and what robot to build will be determined by the solution value. Okay, the whole world is approaching us. Actually, I don't need to promote this. First, the Nobel Prize in Physiology, where actually they are just explaining how do humans feel, but they keep talking about touch. They think this is solution of touch. Okay, that is I think this is way too simplified. Conclusion. And also driverless cars. Okay, driverless cars, they try to avoid things. I wrote the article. I say that driverless cars are for the birds and fishes. They try to avoid things when they flying around. But for humans, and also animal, insect, the most important thing is contact. It's collision. It's not avoiding collision. Okay. Finally, the robot, we see lots of rockets landing and docking. Okay. This is really something that is embarrassing because the landing is very clumsy. There's no touch. Okay, it just come down. Straight from a parachute. So basically, our organization, Pole Science Institute, feel there's no robot today. Okay. The reason is a robot is an intelligent machine which can safely come into contact with an uncontrolled environment. So it should survive completely autonomously. And there is the problem of touch is a 300-year-old problem. It's called the contact problem. Newton couldn't solve it, Hooke couldn't solve it, and now we are addressing it. So what really amount to is the society need to become as intelligent as Daiyu Wu, who is the Chinese father of physics, in thinking about this solution of touch. And they also need to go into artificial software. John von Neumann, C.V. Ramusi, they need the complete automated software in order to have sensors which match the human ability to sense. Finally, the most difficult is fuzzy logic. Okay, you can never be precise in touch. You have to define the range of tolerance of the, both of the timing and also of the jump pulse, the force you apply in touch. So my feeling is this project for this problem for the society, it's not even started yet. They don't even understand the problem. Okay. Right now, Pole Science Institute is trying to define the problem in its entirety, what it takes to build a robot, general purpose robot with the ability of touch. So what I'm suggesting is we have a double hitting test, where I call it simply Ching test, my test, which versus tuning test. Tuning test is really not serious. It tests the common sense of a computer. That it doesn't really make, it's kind of just a not serious test. But this robot test for double hitting, you build a robot which can double hit. First, it must see where the ball is. Then let's move over to it and apply a jump pulse. Okay, timing, precise timing, almost precise timing. You have to figure all the range of tolerance of the sense, of the physical motion. And also you have to have some kind of seeing with the mind. You do not see it with senses. Okay, this guy got Nobel Prize. He thinks the sense is most important. Sense is just part of it. Even their sense requires fuzzy logic to tell them what is the range of tolerance for feeling this at the sufficient time for you to react. In touch, it's not possible. Okay, once you touch, the time involved in touch is much shorter than the science to react to touch, to the feeling. So basically, I'm just this is the subject. I will encourage you to continue to talk about this one subject. It's enough. It got everything. You see. And unfortunately, today we don't have a robot. They all think they have a robot, but I don't think there's too. Also, I think there are too many hurdles for them to overcome. They got to be as smart as Dai Wu, as smart as John von Neumann, Ramosi, in software, and they got to understand lofty Sade, father of fuzzy logic. So basically, this is it is the central question. Okay, and also you asked me about all this safety situation. This is,
Yes.
it's kind of funny. I suggest once I jokingly suggest that people should fight their wars in space, robotic wars in space, to see who can win. Don't try to fight where there's humans. And this is a social science which is not as difficult as life science, but I would say, when robots start to fight a war, it's a totally different situation. My feeling is that politicians were afraid to fight any wars, except against some enemy which have no way to fight back. Otherwise, this robot war is a huge threat to the human population, and it's so big a threat. It probably will stop wars. It's probably more threatening than atomic bombs. So basically, my feeling is we should continue to talk this project, and there's altogether 3 areas: the physics of touch, artificial intelligence, which is required to sense where the ball is, how to touch it, where's object you have to touch it. Then finally, the most difficult is fuzzy logic. You see, in fuzzy logic, a lot of this they actually is trying to dismantle science, dismantle physics, because physics is about precision. Okay, here a lot of this they come out to say that no such thing as precision. So, and I'm in the process of applying for my student nominated for awards all over the world, and I think the foundation of knowledge should be fuzzy logic, replacing exact logic. So that would dismantle physics, and the
Thank you, sir.
consequence of this fuzzy logic is. Before fuzzy logic, no solution is valid because Kurt Gödel think logic is incomplete. Kenneth Arrow thinks the logic is inconsistent. So no solution valid before fuzzy logic. After fuzzy logic, all the solution becomes valid as long as you define the range of tolerance of the solution. Okay, so there's going to be a huge change. It would all be demonstrated with robot touch, with this double hitting. You see, when you try to build a robot which can double hit, you will face all these problems. And we're not going to do this easily. Okay, technically it might take 1,000 years to complete everything, but we can start in the right direction.
Thank you, sir.
Okay, so
we have
that's
other
it.
speakers. I need to give them chance. Dr. Churchill.
Yeah.
So how you want to analyze today's topic? We have our another friend, Matthew, from Robot Everywhere. So hopefully he will give some practical explanation from his lab. Dr. Churchill, yes. Dr. Churchill,
Hi.
can you hear me? Yes.
Yes, I believe I can. Just a second. Can you hear me?
Yes, we can hear you.
Ah, that is good then. So, hi to all, and good evening if you're in Malaysia time, or good afternoon if you're not. But pleased to meet you, and just to say, robots are a very interesting proposition today. I think we must allow for the fact that it is not a new thing, and yet we are facing it. It is by no means something that is only coming onto the forefront of today. Robots have been with us for thousands of years, literally, and in very many different forms, simple, complex, or whatever you have. We've seen archaeological evidence of the existence of robots in many different guises, from the past, whether in the Babylonian civilization, Egyptian civilization, Persian, and even ancient Greek. So I have no doubt that some of those things that we are seeing today as pivotal, they might have been, also in the past. And perhaps, the complexity of the issue of robots in our lives has never been as great as it is today, and that is, well understood. However, if you look at ancient evidence of utilizing very, very powerful robots, we might find that the definition of robot has changed over time, but it has not changed the applicability of robots. So if they actually have a value, economic value to life, or economic value to to military systems, they will be with us, no question about it. But I doubt that we will face sort of a mass extinction of human jobs and human enterprises due to robots. Yes, there will always be, an augmented effort to support the work that we do. And I think that the fears that a lot of people bring about robots are misguided. And whether all the fast food workers will lose their jobs to the robots, well, I'm not afraid of that. Neither am I afraid that, high value industrial work will be lost to the robots. So I am with you all in the sense that, this era will not be defined by robotics in any which way, but it will be supported by robotics in very many different ways. So thank you very much for sharing.
Thank you. Matthew, can you hear me? Matthew, I think he has.
Certainly can hear you.
Yes. I know that you have different things to share with our audience, especially you have lab for develop robots. So what you want to share with our audience?
Well, we've been making robots since 2007. Not only drones, but also industrial robots, autonomous robots, and so on. You can see the smallest thing we've ever made. There's a ferrofluid-based actuator over there in the video. And the thing is, who owns the robots? 200 years ago, it was a matter of who owns the means of productions. That's still the case. Who owns the robots? Because if Amazon owns the delivery robot, you're in trouble because now you depend on Amazon. If you, let's say that you own a restaurant, you own a delivery robot, then you have control over it. When you buy a robotic toy, when you buy even a car at this point can be considered a robot because most new cars have some manner of autonomy. When you buy something like that, who controls it? If you buy a tractor, the tractor's firmware is locked so that you cannot do your own repairs. Then if you buy it from John Deere. But if you buy a tractor from FarmBot, which is a cooperative open source effort in California, you own the thing you bought. You own the software. You have the tools that let you edit, modify the software to your needs. So yes, robots are a force multiplier. The question is, who owns the robot? Who owns the software that sits on the robot? Who is in control? And who must be in control is the person using the damn thing.
Mm-hmm. Thank you. Professor David Smith, I believe that Jason has a question for you. if part of human information process is chemical rather than digital, which I believe is true, how can we make an analog of what is robotics?
Well, really, when you look at the human information process, it is really more signal-based than either chemical or digital when you look at it together. You know, our nerves, our neurons and things are the ones who are actively collecting the information. We have chemical reactions in there too. We're actually beginning with, as we've talked about some other programs, seeing more biological type of chips beginning to be deployed in robots. You've seen neural networks being used in the thought process, and really his question and the one on how do we implement artificial intelligence in robots kind of go together, because the human body analogy is a very complex one, and over the last 100 years we've really changed our views on the way the brain works, you know, on how the body works, and we begin to see how it can go into other areas. The really very advanced robotics we see where you can have robots do backflips now. You can do robotic dogs that can do almost anything that a real dog can do. And it's by combining parts of artificial intelligence, combining computer vision, combining advanced sensors, combining machine learning and others together in the same way we kind of sense what's around us. And we can kind of put the logic pieces together in a very parallel way to be able to do complex actions. And some of the robots are electrical in their actions, some of them are hydraulic, so it's chemicals in there and others like that. But really, the complexity of AI and mechanical engineering really come together to make robots capable to do the things we're wanting to do. And part of Jason's question really gets into how we apply logic. And logic is, as we begin to go to the biological base, the neuromorphic type of computing we talked about earlier, those are going to go into more of the advanced robots as we go forward.
Thank you, Professor Rob. There are a few other questions. I want to take one question for you. Mahdi, how would we navigate a robot without GPS?
Sorry, the question is again,
How would we navigate a robot without GPS?
Oh, that's an interesting one.
Yeah, so the number of ways to navigate a robot without GPS. In fact, in building, GPS is relatively inaccurate. You can navigate using sight. The latest Roomba vacuum cleaners, for instance, largely use sight, and the robots that I believe BMW has just started to deploy in one of their factories are largely sight-based. You can use tracking, where you put a metallic strip down on the factory floor, and the robots follow that magnetic strip. You can conceal it underneath the concrete or underneath the carpet if you need to. That was what was done before we moved to sight. You can triangulate, use multiple radio signals placed around the facility, and then the strength of the signal coupled with the positioning of the signaling unit can position the robot in a two-dimensional, and sometimes even in a three-dimensional space, depending if you're talking about a robot that is flying or driving. But you don't need GPS. GPS is handy if you've got an autonomous robot that's working outside, where it can easily see the GPS satellite. But the GPS use in building has not proven to be that great. The dithering, the amount of error in the GPS signal, which I believe we've gotten down to about a yard now, is still too broad for in-building navigation, and for the most part, it's too broad for vehicle navigation as well, which is why most vehicles are using a variety of autonomous vehicles are using a variety of sensors including visual, LiDAR, radar, and even sonar in some implementations. Like people, we don't use GPS to get around. Robots don't need GPS to get around either. We had two earlier questions we didn't address. One was, what are the robotics laws? The robotics laws that have been brought forward were from Isaac Asimov out of his 1942 short story Runaround. The first law, a robot may not injure a human being or through inaction allow a human being to come to harm. A second law, a robot must obey the orders given it by human beings, except where such orders would conflict with the first law. And third law, a robot must protect its own existence as long as such protection does not conflict with the first or second law. There've been additional laws added over time, but those are the three that we tend to use. Yes, from a science fiction author, but they're the laws we've got. And nobody enforces them. So that's certainly a concern as we're moving to militarized robots. Robots go back all the way to 400 BC. However, modern robots, we're talking about the first robots, go back to the 1950s and George Duvall. He's an inventor out of Louisville, Kentucky. He patented the programmable manipulator called the Unimate, and the company was Universal Automation. So the robots as we know them, industrial robots, go back to 1950, but the actual use of some form of automation actually goes back to the Egyptian water clocks, which is 3000 BC. So we've been working on this for a while. And we've had robots that could deliver bread going back to 1557. So not the most practical robots on the planet, but we've been working on these for a while.
Thank you, Professor. There is more question from audience for Professor Hak-Ching. From Onika, why do we implement artificial intelligence in robotics? Dr. Hak?
Yeah, okay. Yeah, artificial intelligence is, mostly in sensors. Okay, you have a deep learning. Deep learning really, all the artificial intelligence by Minsky has failed actually. Then they come up with deep learning, and which is just, look at the pictures of all the Go games in the past of masters. Then they try to remember large data, and whichever move people make, they just get a master's move and to do the next move, which is effective, in diagnostics, in medicine. So artificial intelligence will correspond to human neural network. Okay, what I'm suggesting, neural network with unlimited self-generating software cells. So you need to match the brain in its power to really do good artificial deep learning. Also, if you continue to use partially automated software, eventually we're going to get into complexity crisis. There won't be enough people to manually update the partially automated software. So there's more problem introduced by computer science than we realize. Okay, all the calculations should be done all the consideration should be taken to infinity, long term. Today we just go for short term. As long as it can make money, as long as it, it would, no matter long term or short term, it would be accepted by the society. Okay, this money-oriented society is a big problem. Okay, I have a question, general question for all the speakers here. What is the difference between an intelligent machine and a robot? Okay, this is the basis of my talk. You see, all the robots today are just intelligent machines. I don't believe there's any difference. You really want to do robot, you are trying to imitate the human. Okay, the first thing is a human being can go out, and if a car comes, he will he will avoid it. A robot, you put him there, he doesn't know, he has to avoid it, you see. Not only that, okay, this inability to come safely into contact with the environment. Okay, this takes artificial intelligence. You got to see the environment. Okay, artificial intelligence. Artificial intelligence play one of the three central role in robotics, the sense. Okay, so basically we need to have a new definition of robot, And the way they are doing is for driverless car, they have to build roads, which is the environment, completely control the environment for the car to run on. And they try to avoid the most important question, that is when the car have a collision. Okay, another way, saving life is more important than drive around. Okay, saving life is the most important question. So you've got to have some kind of touch mechanism which will make the collision so severe. Okay, it's all neglected in their current thinking. I think very soon they will all realize this. Don't worry. Okay, the whole world is rushing toward both sides. We don't have enough time to face them, so we're facing our own students. For next 2 weeks, I'm going to talk just to our pole science students. I will explain to them the physics of touch, the physics of jump pulse. Okay, we'll take it step by step. If anybody want to join us, can look me up in Facebook or LinkedIn, and they can come in and participate. I don't think the society is really the money-oriented society is the problem. Okay? Anything that makes money, regardless short-term, long-term, it's okay today. Okay, now today we have come to the end of the short-term, so we are facing with crisis, all kinds of crisis, financial crisis, complexity crisis, health crisis, environmental crisis, you name it. So it's all here. Okay, we need to look long-term, and also non-monetary return, which are good for the people, not just for money. Okay, so we need to go into from money-oriented society to a knowledge-oriented society, where people will be rewarded for contribution of knowledge, not the contribution of money.
So to answer your questions, the intelligent robot is a subset of robotics. Robots include unintelligent actuator arms that are used in manufacturing. The broad definition of robotics goes back to 1950 and really just talks about machines that can be programmed to do things. They aren't intelligent at all. Intelligent machines are a subset. So that's robotic. The robotic definition is actually pretty broad.
Yeah. Okay. That's good. Yeah, that's good. We choose to differ with that kind of thinking. We don't actually we are already dissociate with the established knowledge completely. So it's not unusual for us to take that kind of position.
Thank you, Dr. Churchill. Are you with us, Dr. Churchill? Okay. Matthew, can you hear me?
Absolutely.
Yes. There are a few other questions from our audience. Can you help us, or
gladly? What can I answer you?
Okay. From Alea, her question is that how can we determine the degree of freedom in robotics?
Well, ultimately. Sorry.
Yes.
So when you say degree of freedom, that's actually a technical term for how many points of movement a robotic arm or a robotic chassis has. So for example, a tank robot like the one I'm showing here has 2 degrees of freedom. Effectively, it means that it can move its left motor forward or backwards and its right motor forward and backwards, and that is sufficient to allow it to move in all directions on a 2D plane. I don't know if you mean metaphorical freedom, The answer is very easy. We give the robots as much freedom as they need to do their job. These things are not sentient, and they're not going to be sentient for a long time. Now, I'd like to address something that Dr. Enderle said a while ago, and that's about machine vision. Here's something interesting. This little rover here, was not programmed. Somebody's on Skype. Hello. I'm getting feedback here.
Okay, Professor David Smith, I think.
Sharif, I love where the discussion's going and where we're doing some of the elements. One of the things I was looking at some of the comments in the chat and about where some of the trends are and what it's doing. You know, we're seeing increased adoption of collaborative robots, and collaborative robots are helping to really move us down the road to the different elements. And
I think I was muted.
And there's different questions in there as you look at that. One of the next trends is we're seeing really robots being used a lot for supply chain automation and pushing that. And AI, we cannot underestimate the importance of AI within robots to increase their capabilities, to help them learn on the job, to help them make their actuators, their sensor, their vision systems, their smart software more responsive in real time and begin to see those things. Huge advances in robotic vision systems and huge advances in robot sensors, which are going to play big on this. And there was a question in the chat about how do you drive the systems? And many of the early robots were analog robots. Mm-hmm. And what we're seeing today is really the push to move more and more digital in the robots and how those work and how they can begin to be used in there. And, you know, I almost want to go to Boston Dynamics homepage and just let the people see the little video on the top of it, to see all the various forms of robots that Boston Dynamics produces, which are some of the more advanced ones in the world, and see that what they can do, how they can work in a factory, how they can work on in real life with their humanoid robots. They're robots that look like dogs and other things, but they're very functional and they're really achieving a need that's very important.
Thank you. Mr. Matthew, can you hear me?
Yes.
Yes. Sorry, I think you get a call. That's why I have to ask.
I did not get a call, but go on.
Okay. Anyway. So, what do you want to add about this question? What do you think are the biggest challenges facing the robotic industry?
Right now, we are looking at, I remember it was before my time, there was something called the AI winter, and people were just pessimistic about AI. Now you say the word AI, you get a lot of money thrown around, even for things that have nothing to do with AI. We're going to get my prediction is that we're going to get another period of pessimism when we get to the point where our current deep learning models reach a plateau. We get to the point where they are smart, but not quite smart enough. And I believe that the next thing for us is going to be genetic programming. Genetic programming is not a new idea, but what is new is that we finally have the capability of throwing a lot of hardware at a problem. What does that do for us? It lets us copy nature. Copying nature and improving on it is how we have made all of our discoveries as a species. I don't think that's going to change. That's just how the human mind works. And the way that we're going to develop a non-human mind is going to be by copying evolutionary processes. On that note, I got something to show you. And I really do this time. It's not just a bunch of little rovers that we're showing out just for entertainment. So this guy here was not programmed. This uses a genetic algorithm. It has no idea what its sensors are, what its motors are. You can see it be born in a minute. It's going to wander around, do nothing, and then it will obey its task of figuring out how to navigate an environment, and you can actually watch it get better and better at it. It's tentative, it just kind of hugs the wall, then it becomes more confident, and by the time that it has to see doors and door frames and a more complex shape, it is much more sure of what it's doing. I want to point something out. This video is from 2009. If you're in school now, you were in elementary school when this was made. This technology has been available for a while. Everything you see in this video cost about $100 back then, and it cost about $20 now. This is not the future. This is the present. This is what we already have. In robots, which drive system is best for, how can you add robot vision and manipulator arm? Your best option would be a CMU cam. There's the CMU cam 5, it's called the Pixie. I am personally a big fan of the CMU cam 4, which is the predecessor of it. It's based on an 8-core microcontroller called a Parallax Propeller. If you can buy a CMU cam 4, get that one because it will be lower resolution, but the multi-processing architecture will make it a lot easier to program. As far as operating a robot arm, there's various things you can do. You can do servos. You can do gear motors and the limit switches. You can replace the limit switch with a laser pointer if you're brave. You can do a number of things. There is no one best way. Here we see a stepper for this, a gear motor for this, and the servo for the little arm cup. There is no one best actuator. It depends on what you're doing. My suggestion is start with the gear motor with feedback. It will not be the best at anything, but it will do a good job at everything. And you can see if that works. And if it doesn't work, you get a servo or you get a stepper, depending on your application. But if you want to suggest a practical suggestion quickly, start with a gear motor with a rotary encoder.
Thank you. Thank you, Matthew. There are more questions. Professor Rob, from Mr. Prakash, how can we add robot visions in manipulator arm?
Dude, I just told you, you're using CMU cam.
Yeah.
Okay.
That question was just answered.
Okay. So I have to go for final and concluding remarks. I want to start from Professor Rob. What's your concluding remarks for today?
Well, robotics is one of the most exciting industries at the moment. The development into current robots goes back decades, but it's all coming together this decade. And the pandemic has accelerated interest in robotics rather substantially, particularly in areas the hardest hit by staffing shortages. So restaurants are looking at them much more aggressively. We had trials going on years ago, but nobody seemed to pick them up because workers were cheaper than the robots were. That's flipped. And suddenly we've got a lot of interest because a store that's closed because they can't staff it isn't making any money. And suddenly the robot looks a lot more cost effective as a result. Autonomous cars have had a great deal to do with our recent advancement in robotics. The improvements in computer vision, the improvements in processing power, and the amount of processing you can do at low energy has increased dramatically. In fact, just this week, IBM announced yet another new process to keep Moore's law moving and increasing the overall density of the brains we can put in small form factor robotics and drones. So it's going crazy. This is an area that's unlikely to run out of steam in the foreseeable future. And for those looking at a career that could be fascinating going forward, this is it. One of the other areas that's seen a lot of advancement are robots that can emulate humans. We're not at the point where we've crossed the uncanny valley yet. Most of the ones I've seen so far are just over the top creepy. But we're getting there, and the promise of being able to create robotic companions is approaching faster than I think any of us realized. Though if we look back, we were talking about these things in the 1950s, so I guess fast is a matter of perspective. but it's a great area to research. It's a fantastic area to live in, and it blends everything from mechanical to electronic engineering to advanced computer science in one platform. And so there's a lot of opportunity for bridge skills, people that have covered a variety of these different technical areas to step in and make a big difference in this segment. So it's a wonderful opportunity.
Thank you, Professor. Professor Ching, what's your concluding remarks?
Okay, let's go back to the situation with the current knowledge society. Okay, what is happening is human being has science. Okay, so we try to make all subjects sort of following science. Okay, so science has been applied to military, it's been applied to business, yeah, applied to computer science. But I would say the only successful application of science is into military. Okay, the business, we have financial crisis nobody can solve. I know they cannot succeed. Also in software, it's a partially automated software. The computer itself it's a dangerous. It's produce all this software which has to be manually maintained. Okay, and now we have to go back to science. How do you make robotics scientific? Robotics is not even scientific. Okay, so my suggestion is to go try to solve this problem which has been with us for 300 years. 300 years ago, Isaac Newton and Robert Hooke had a debate on this problem of contact. You know, if you want to push something, you have to make contact first. But if you make contact, the hand will bounce off. If you don't know how to contact, you don't solve the contact problem. So we need to go back to the old problem 300 years ago and solve this contact problem. Okay, that will bring robotics start to look like into science. Okay, also we are bringing sports into science. We show people the secret consistency in sports. You know, secret consistency in sports is prolonged contact, and that will make the contact time a little bit longer so the player can guide the ball. All the professional player knows this. Okay, they're practicing this. Okay, this is in practice, not just a theory. Okay. So we need to solve this problem. The 25 variable problem of contact. Today's scientists can only handle 10 variable problem. They can only, most problem are 5 variable. A Nobel Prize winner will be able to handle 5 variable, one old, one new. Okay, above 10 variables, nobody can handle. Dai Wu is one of the person who can think this problem of contact. And if you want to go into software, then that's 500 variables. But if we can solve the software problem, then we have a situation where all human beings over the age of 6 can start to contribute, can write software, start to contribute to knowledge. Okay, that's a big jump, but it's the problem. The complete automated software is a difficulty. That's really innovation, and also this genetic programming, all this stuff. You know, they try to do this. You know, we already solved it. We identify DNA as a complete automated software. So we are the person who, we don't need people do experiment to find the helical. We solving the problem of complete automated software is the theoretical discovery of DNA. Okay, so you know, this is, I think it's more difficult. The easy problem to solve is the contact problem, which has been with us for 300 years. Okay, the society need to put their resource to solve this easiest of all the posters problem.
Thank you.
We cannot stress
Thank
more.
You. Thank you, Professor Chief. Dr. Churchill.
Okay, thank you. Yeah.
Thank you. Dr. Churchill, are you with me? Okay, then Matthew, what's your concluding remarks?
It used to be that you had to spend a lot of money to get started with robotics. This is no longer true. You can set up a fully equipped shop. You can get a 3D printer. You can get soldering equipment. You can get a laser and a mill to make printed circuit boards, all for 2-3 months salary, probably less. So there is room. Don't think that because, Boston Dynamics already doing this and that, or because Amazon is already doing this and that, there's no room. There is room. There is room for innovation. There is room for small businesses. There is room for you to make an important contribution. If that's all you want to do. If that's not something you want to do, you can just use a robot to say hello to a cat.
Thank you. Professor David Smith, what's your concluding remarks? Professor David Smith.
Yeah. Robotics are going to be one of the hottest growth areas of the next multiple decades. And it is, as we talked in earlier, it touches so many different vertical markets. It touches so many different industries, so many different science specializations, that it truly is one where it's going to take the total village to advance and make it work. The advantages of it are multiple fold. There's discussion of the privacy impact of robots. There's discussions of robots taking jobs away. But in the whole, the genie's out of the bag with robots. They're going to continue to progress. And today, as was mentioned, I can get started at a very low cost with robots. The fact that if I begin to look at, as we talked about on a prior show, the cobots, the collaborative robots, they're going to constitute about 34% of all sales by 2025. And another statistic out of McKinsey is that 88% of businesses worldwide plan to take some type of automation, often including robots, into their infrastructure. So it's going to have a massive impact. A lot of opportunities for education institutions, a lot of opportunities for entrepreneurs. I can pull robots in without a lot of specialized knowledge today because of all the advances of applying AI, all the advances in sensors. And it's one that companies, individuals, universities, governments really need to stay up to date on, because the impact is going to be so broad.
Thank you, Professor David Smith. Dr. Churchill, what's your concluding remarks for today?
Hi.
Dr. Churchill,
I find it I find it most interesting that we are talking about robots today, because a couple of things have happened. First of all, there's been a technical announcement from NASA that they are looking to actually, in light of the needs that we have in space, to have all flights, for certain advanced technologies in space to be robotic. And I think that's kind of huge. So there is a conference coming up in which this will be discussed. However, now we are looking at commercialization of space. All of that is going to be robotics. So yeah, there is great progress. I think there is great promise. And certainly, there will be companies that would benefit from this windfall. But however, the innovators, they're always looking up. And that's where I think that the greatest application of robotics would be. Let's all look up in the stars and the sky and hope for the best. Thank you very much. I think the future for robotics is brighter than ever before.
Thank you. Thank you, Dr. Churchill, Professor David Smith, Professor Rob, Professor Ching, and Matthew for joining today's session. I request all of our audience, please share our content as much as possible. Thank you. Bye-bye and take care.